Busways. Busways is one very good approved wiring methods. The best application for busways, why the reason why we talk about it right here in industrial, is actually in an industrial, in manufacturing. If you have a manufacturing floor, any type of concentration of loads, busways would be probably your wiring methods of choice. Your wiring methods of choice. So when would we use tower busway, my friend? If you have a manufacturing floor, multiple machines that you need to feed these multiple machines from a power system. For a second, we guys have 10 students here. Assume these 10 students, each one of you is a three-phase machine, 15 horsepower each at 480. 277, right? And you need to power these machines exactly where you're located. The best application, wiring methods for this application is to run a 480 277 busway busway right above your head with disconnect switches and fuses, and have an SO cord hard usage and tie it directly to each one of you as a machine, if you're a machine. Does that make sense? That's really the whole idea of the main use of busways. Concentration of load in certain area for manufacturing. You're not going to find a busway, guys, in an office building to feed loads in an office building, because it defeats the purpose. It doesn't get you what you want. Concentration of load, heavy load, as in machines and motors in a small area. That's the main application for plug-in busways. We'll talk about busways, guys. The two major parts of busways are two major. One is called feeder busway, and the other one is called plug-in busway. The feeder busway, if you look at this, that busway that comes out of here all the way and comes back, they call this one a feeder busway. Why a feeder busway? Because it's taking major chunk of load, and taking it to a different destination. If you can look at this one, the same thing. If this particular one right here, it could be considered a feeder busway. This section here also is a feeder busway between two pieces of equipment. Can you see that? Feeder busways. These are feeder busways. The feeder busways, here's the difference between plug-in busway and feeder busway. A feeder busway will take a big chunk of load from point A to point B, and nothing in between, for the most part. Nothing in between. That's a feeder busway. So it takes 1600 amps. I don't know what the load is here. Let's just say this was 1600 amp load at 480 volt, taking it from this switch, from this MCC all the way to this destination. Then from here, what they do is they have a plug-in busways where you can tie plug-in busways, and I'm just imagining here, plug-in busways where you can tie to equipment and machines. Plug-in busways where you can tie to equipments and machines, and from here you can tie to different equipments, different machines, and I'm imagining here, so different equipments, different machines that you can tie to. Okay, so the red one, I highlighted it guys for you right here, the way they did them in the manufacturing floor. So look at the blue one. The blue one, as the feeder busway goes along the perimeter of the busway number one, feeder busway number one, goes along the whole perimeter of the room. Can you see that? And there's a feeder busway number two that goes in the middle of it and cut it into, like, tee it. Can you see that? And from these two feeder busways in this project, they're feeding two things. The first one right here, the one that's going into the parameters, is actually feeding multiple panels at the parameters, and the one that's going in the middle is feeding multiple plug-in busways. Here's plug-in busway 1, 2, 3, 4, 5. Can you guys see that? How they take a big major feeder busway and they tie to it a plug-in busways to feed multiple loads. Any question, guys, about what a feeder busway, what a plug-in busway? The difference between a feeder busway, it's meant to take the power from point A to point B, and there might be some tabs in the way, they call them tabs, no plugs though, tabs in the feeder. Now in a plug-in busway, it's meant to take the power from point A to point B, and right between A and B, you will have multiple tabs at almost every 3 feet. Every 3 feet, you will have or so you will have a place where you can tab the power and feed machines.
Is that tab or tap?
Tab, as in tapping it. Yep, as in tapping it. Any comments, guys, about the plug-in busways and the feeder busways? Plug-in busways and the feeder busways. So if you guys are machines, and that would probably, I don't know if I would run a feeder busway. I probably will have a plug-in busway come out of here all the way over here and run a plug-in busway all the way above your head and tie you without feeder busways. Now, if I have to tie, if every machine in this room, if every room has multiple machines, the best way to do it is to run a feeder busway across the hallway and tap from this feeder busway and bring a plug-in busways to every single room to feed these loads. Any question, guys, about the feeder busways versus plug-in busways? Plug-in busways pre-manufactured, where every 3 feet or so, 2 to 3 feet, you can plug in a load. Feeder busways, you only can take power at a predetermined section. You can't just take power every 3 feet. Usually every 10 feet or 12 feet, if you want to tab out of this feeder, you have to have a junction, big junction box, and tab out of this feeder busway. So for example, you can have a 1600 amp feeder here, and each one of these is, say, 225 amp, 225 amp, 225 amp, and let's just say this was 1000 amp, and each one of them is 225 amp, 225 amp. These ones, guys, are easy. 1600 amp going across. I believe its feeder number 2 is 1000 amp, and each one of these plug-in busways are, as a matter of fact, is a 225 amp. 225 amp. Ashley, one thing I want you to pay attention. Every time we go, can you guys see the orange thing? These are the plug-in busways. When you tie a plug-in busway to a feeder busway, what do you need? When you tie a plug-in busway to a feeder busway, right here, what do you need? This one is 225 amp, and that one is 1000 amp. Can you tie a 225 amp piece of copper to a 1000 amp piece of copper without having an overcomputation device? You can't. So the rule, Tom, my friend, is every time you tie a plug-in busway into a feeder busway, you have to have something called overcurrent protection device to protect that feeder busway, to protect that plug-in busway. So right in here, you will have a circuit breaker 225 amp to protect this section, another circuit breaker to protect this section, a third, a fourth, a fifth, a sixth, a 7, 8, 9, 10. Each section will have a circuit breaker that protect that section. Does that make sense? And right in here, the feeder itself will have, I think feeder number 2 is, what is it, 1000 amp? Feeder number 2, it's actually here, feeder number 2 feeder number 2 is 1600 amp. Feeder number 2, which is 1600 amp right here, will have a 1600 amp circuit breaker protecting it. Can I get you guys to understand that feeder number 2 here is a 1600 amp feeder? You have a 1600 amp circuit breaker protecting it. So, and then you continue all the way. Then you come over here. Every time you change the amps to a lower amp, you have to have an overcomputation device. So I went from 1600 to 225. Overcomputation device, overcomputation device, overcomputation device. So 10 overcomputation device, 225 amp each, 3-phase to feed these sections. And then Chris, now these are the plug-in section. And right in here, what they do is they have a fused disconnect switch or circuit breaker. Then you have like 30 amp. Suppose this was a 30 amp load. You have a 30 amp fused disconnect that feeds the machine. Done. So that would be, say, if it's a plug-in, that will be a 30 amp fused disconnect tying to this machine right in here. Any question about feeder busways, plug-in busways?
I assume it's considerably more expensive than.
Absolutely, absolutely.
4 times, 10 times.
I like percentages. You know, man, you can hold me accountable on that. I don't think it's 4 times though. I would say probably from 50% more to twice. Yeah, 100 to 100% more. So if the system is to cost you, say, $100,000 to do it with conduit, it might cost you $150,000 to do it with busways. Any question, guys, about this? But take this. How many conduits and conductors you need to carry 1600 amp? It's not just, guys, the wiring. It's not like to do this in conduit and wires. To do this system in conduit and wires, you need a lot of switch gears or a lot of panels to do them in conduit and wires. I can't. But imagine 10 of the students, if 10 of you are machines and I need to do them with conduit and wires, how many conduits and wires do I need to pull? I need to pull 10 conduits for the most part, if I want to have dedicated conduits, and 10 sets of wires. And I pull them all the way into the panel. That's the alternative of plugging you into a busway, plug-in busway system. Any question, guys, about this? Everybody understand the difference between the blues feeders, the orange as plug-in? Anybody knows what the pink is? What are the pink, though? Can you guys see these pink? These pink, there's 3 sections of them. Section D, Section C, and Section B and Section A. A, B, C, D. Can you guys see that pink ones? If you're looking at yours, can you see your pink ones? These are the trolley busways. These are the busways, the trolley busways. What's the difference? We're going to talk about trolley busways. The difference between a plug-in busways, plug-in is permanent for the most part. Trolley is movable. So you can move if I have a machine that's weld, I will weld here, and I will weld also here, and weld over here. So if I tie it to a trolley busway, I can pull that cable while connect the energizer, and then pull it to every location along the track to utilize the machine. Right? If I need to, let's say a big welder sitting here, I want to weld in this area. When I'm done, I'm gonna pull the machine, roll the machine while connected, the energizer first, and pull it to this location, weld here, and continue along the track. That would be a great application for a trolley busways. Trolley busways, the connection moves. Unlike plug-in busways where the connection is permanent, you have to physically, mechanically unplug it and plug it somewhere else if you were to move. Any question, guys, about the 3 types? So we'll talk about the trolley. So we have our feeder. The first type is feeder, plug in, and trolley. If I spelled it right. Trolley busways. Plug in and trolley busways. Any question about these 3 types? What does the feeder do? Take a big chunk of power from point A to point B. What does the plug-in do? Take a power from point A to point B, but plugs in between. What does the trolley busway do? Take the power from point A to point B with connected power that can move while connected. With a chunk of power that can move. Any question, guys, about this? So everybody see where the feeder busways, plug-in busways. Here's how they represent them. First, in terms of coming out of the switch gear, 1600 amp going to across inside the room right here and feeding all these plug-in busways and trolley busways. The second one is 1000 amp going along the parameters. You can see the 1000 amp and feeding panels. It's feeding multiple panels with the transformers. Multiple panels with the transformers. Any question? Okay, so that's your plug-in busways and feeder busways. Let me go quick into our presentation here. I'll talk about the code, guys. So benefits of using busways: it's less copper and less wire, and conduit and less labor. Really much less. Imagine if the system that I showed you here, if you want to do it with conduit and wire, there would be tons of racks of conduits and wires. Common application for busways, manufacturing floor, period. That's the major use of busways. Component of busways, we'll talk about it in a second here. You have sections. The busways are made out of sections and connections, where you have to connect every 10-foot sections. You have some box to connect these sections together. If you need to tab out of a feeder busway, they call it a tab box that you tab out of it. If it's a plug-in busways, you have a plug that you can plug it into and tab out of these plug-in busways.
What if you had a really long haul of office building that you used, or you used to go back to pipe?
To feed what? What's in this?
High amount of current over a long haul office building.
You can do it. Yep.
Then would that still be a method of choice?
A big amount of current? Yes. As a matter of fact, we have an example that you guys are going to do, and we do it to Boston Scientific. They have a plug-in busway in their hallway, and and they're feeding all the rooftop units. big chunk of amps, rooftop units, the cooling, heating units on the roof. They're coming from the roof and tying to this busway. That's also another method of choice. Absolutely. We'll talk about the support system that we can use. I talked, guys, about where you use it, busways, taking it from point A to point B, replaces the panels. So basically, it replaces all the panels that you can imagine here. And what is a busway? Bunch of bus bars, copper or aluminum, and ventilated inside a ventilated enclosure. You'll see. Look at a couple of pictures in a second here. Typically 10-foot sections, typically, but you can order them in more or less than that, if needed. There are different types of connection. You're going to see, guys, how they, if you want to go vertical, horizontal, there's a lot of hardware that comes with it. It's a complete system. There's angles, T's, and all this good stuff. There's a couple of things on the long distance. This is really interesting. Transposing position of the bus bar. This is a concept of reducing the impedance overall. If you have, let's just say, you have 600 feet of busway, and you will run this busway 600 feet. What they do, guys, utilities use them all the time. If suppose that phase A, phase B, phase C. This is phase A, phase B, phase C. To reduce the impedance, they transpose them. So this becomes, this is phase A, this is phase B, and this is phase C. They do transpose the location. By doing it this way, they reduce the impedance of the AC system. Who cares? Less voltage drop, less losses in the line. So that where they call it transposing the buses, moving them from one location to another, flip-flopping certain phases. So reduces the impedance. Magnetic field effect, reduce the magnetic field effect. Opposition to the flow of current is less, so you have less losses and less voltage drop. Less losses and less voltage drop. Utilities use this all the time in the transmission line. If you see them, every say 10, I'm just going to pick 5 miles or so, they flip-flop the location of phase A. A, B, C becomes C, A, B, or vice versa. By doing it this way, guys, they reduce the impedance of the system. That's all what you need to do. This is done in the manufacturing. The system that we were talking about, guys, in our building is we have feeder busway number 1. It's 1,000 amp. Now, how many conductors 1,000 amp you need to carry? A 1,000 amp, guys, to carry a 1,000 amp, you are looking at 500 kcm will give you 380 amps, right? So if I need 1,000 amp, how many of these conductors do I need to carry? 3 of them? Yep, 3 without using calculator. So that will get you 3 sets of 3 conductors, number 500 kcm. 3 sets with 3 conduits, sets of conduit. Can you guys see the advantage of using a feeder, 1,000 amp feeder versus a 1,000 amp bus ducts that most likely is going to be, say, 8 inches by 8 inches or 6 inches by 6 inches, and moving that bus duct from one location, one mounting, one route. Can you guys see the advantage of that? You have handhole openings where you can connect into these feeders. Every joint, this is for the feeders. At every joint you can tab into it. This is not tab, this is just connection, where you can take a big chunk of power. You can tab the power every section again from the busway. You can tab with anything you want. You can tab with cables or conduits. Most of the time you can SO cord. You can tab with a disconnect tied to SO cord. You can tab with a conduit out of it. So the tab out of a feeder can be in any wiring methods. For example, if I have a feeder right here, can I bring a conduit to a junction box inside the feeder and take a 225 amp feeder to a panel here? No problem. You have to have an overcome protection device. No problem. Any question, guys, about the feeders? Chris?
So these circuit breakers, if that's what you're using, are all pumped up in the air.
Absolutely.
So you have to be a little careful when you put those.
Absolutely. So they have to, here's my feeder coming in here, and I want big chunk of load. Here's my, let's say 225 amp breaker. right in here, and I come over here and I tie to 225 amp panel. No problem. And this one is 1000 amp. Here's where you can take a conduit, EMP conduit, tie it to a box that has an overcapacity device, fuse or circuit breaker, and tap to a panel, or like you guys we were showing, you can tap another plug-in busway from it, another plug-in busway. So this will be my plug-in busway. If you look at the picture that we had, so here's another, and let's just say this is 400 amp, 400 amp fuse, 400 amp fuse. So here's a 400 amp fuse right in here, feeding a plug-in busway, and also a 225 amp circuit breaker or fuse feeding through a conduit and wire a panel. That's what they're doing in feeder number, the feeder number 1, as a matter of fact. Yep, feeder number 1, tying to a panel or a circuit breaker. To a circuit breaker. Any comments, guys? Yes, sir.
So substations kind of
Yes. Tell my friend, if you look right here, here's where the substation is. The substation has 2 disconnect means, 1600 amp and 1000 amp, and these 2 disconnect means, fuses or circuit breakers, are actually feeding the whole load in the whole building. The substation has only 2 circuit breakers. That's a major advantage of using busways. Busway 2, guys, and then the one in this book is 1600 amp. Now, Chris, do me a favor. How many runs of 500 do you need to carry KCM? 1600, 350. Do you have your calculator handy? 1600, to give you an idea, divided by 380. So we have 4.2. You can't go 4.2. It's almost 5 sets. Now, actually, you're going to bend 5 conduits. You're going to pull four conductors in these 5 conduits, probably 3-inch or 4-inch conduits. So instead of doing all this, you can pull all this power with the 1600 amp 480. This will give you guys, that's just to show you the importance of using this busway. Look at the density, the current density. There's something called current density, guys. If you take the amps divided by the square inch of the conductor, they call it current density. The current density of this busway is 1311 per inch. So every inch, every square inch is carrying 1311. If you do the same calculation for compare it with another conductor, similar conductor, conductors can carry 1000 amp for the most part for this application, 1000 amp per square inch. Who cares? For the same square inch of copper, I can carry, 311 amps more if I use this system. Who cares? This copper, this conduit, better use of utilize the system. That's another application where you can use busways. You guys looked at this one. This is the guy, the 1000 amp that we were talking about, 1000 amp. Each one of these is 225 amp, 225 amp, and out of each one of this has a disconnect that feeds a machine. And this, let's just say 30 amp fuse disconnect, right? And you can imagine how these are going to be. Now, Chris, my friend, this is what you guys are going to be doing with your friend Chad. The manufacturing floor that you have, guys, we have rivet families that you're going to grab a feeder busway, and a feeder busway coming from the switch gear, stretch the feeder busway in rivet at a height of say 12, 14 feet, set the height, stretch it, and then you're going to tap out of it a plug-in busway, and right next to the plug-in busway, we're going to put disconnect and wire these disconnects to represent every single machine in the system. This is exactly what we're going to be doing in our project. Same system. The first thing you're going to get your feeder busway right in here, and then you're going to have plug-in busways. And oh, by the way, do not forget the overcap protection device for them. And all these have some overcap protection device here, overcap protection device, overcap protection device, overcap protection device. And there's an overcap protection device right here. Any question, guys, about this? How the system is set together? Typical for manufacturing floor. Okay, so that's your system. This just goes through the hardware, guys, and busways are very important to have a lot of maintenance, bad, well, not bad, but you have to do maintenance on them. You have to torque them. You have to de-energize them, adjust them, torque them, because a lot of copper buses inside them. They have circuit breaker cubicles, they call it. This baby here, right in here that I drew, this one is called circuit breaker cubicle. Right here, circuit breaker cubicle. So the circuit breaker cubicle, my friends, in feeder number 2, bus to 225 plug-in busways. So remember that we have 225 amp circuit breaker feeding this side and the other side. That's called circuit breaker cubicles, 225. Two of them. I'll make you guys go visit the article that talks about article 368 talk about busways. We'll go visit this one. And if you go there, Ashley, it tells you that 17C, it will tell you you need an overcurrent protection device every time you reduce the size of the busway. If I have 1,000 amp and it went down to 400 amp, what do I need? I need to have an overcurrent protection device. Okay, so the second one is the plug-in busways that we talked about, guys. Plug-in busways. The most important thing is the takeoffs or the tab-offs. Tab-offs that you can take out of these to feed equipment. Three-phase, almost always at this system like this, guys, you're looking at three-phase 208 or three-phase 480. Almost always. If you are to install the system, they come up with 2 different sets, guys. If you're going this way or going with an angle, so you can see all the T's and the elbows and the crosses that you can use with them. So I'm going to let you review all these, all the crosses, different type of crosses, the edgewise crosses and the flatwise crosses, different type depending how you want to install your system. Here's how the feeder is, guys. This is really interesting. The bus number two was 1,000 amp. So here's my 1,000 amp coming in here. This is my 1,000 amp. Right in here, I have a circuit breakers. Can you guys see the circuit breakers right in here? This is my circuit breaker, 225 amp. And I also have a circuit breaker, 225 amp 3-phase. And from here, that's how you tap from the feeder to a circuit breaker. And from here, you can take your, so this have to be 225 amp or less, and this have to be 225 amp or less. Can you guys see that? How you tap out of this feeder, typical cubicle. They call them breaker cubicles that you can tap out of the feeder to feed plug-in or panels or anything you want. Any question, guys, about this? This is, what you're looking at is not, this is not a plug-in. This is a cubicle with predetermined circuit breakers that you have to order to take 1,000 amp down to 225 amp plug-in busways. You can see how they do the buses, guys. Phase A, phase B, phase C, phase A, phase B, phase C, and so forth. Any comments, any questions? So busway, everybody knows what the busways is. You need at least 3 cover bars, cover bar A, cover bar B, cover bar C, or usually A, B, and C, sandwiched together with an insulation, torqued, and they have some type of an enclosure to protect it, right? Imagine this is exactly what's inside this panel, except they do it closer together, and they put it probably 6 inches by 6 inches cross section, and they make that baby, depending on the amps, and make it run from point A to point B. Okay, we looked at this one. This is a complete busway system, guys. Most likely it's going to be in an industrial application. If you're doing a commercial building, don't even think about using a system like this. It will be very expensive to use a system like this. You can see why they use all these types of connectors. I don't know if you guys can see the T's, different type of T's that you need to tee off from each one of them. Box and end cable connector you can tap from this. So there's a lot of hardware. You can enter a panel. You can tap with conduits. So there's a lot of application. This is my favorite, where you can bring a big chunk of power from point A to point B with busways. This could be, guys, 2,000 amp. So if this switch gear can give, I don't know what the size is, 2,000 amp, and this piece of equipment could be 2,000 amp. So instead of bringing 2,000 amp from switch gear to the switchboard, they actually bring a 2,000 amp bus to bring all the power all together. No cables, no conduits, nothing. Any comments? Any questions? Comments? Questions?
So if these are 10-foot sections and they need to be torqued on some regular maintenance schedule?
Yes, they put them in maintenance.
Right here on a big factory floor with dangerous equipment laying over home trees?
Well, every manufacturing floor, they have a cycle of maintenance every 6 months to a year, where they can shut down one section to torque it, to maintain the equipment. All these machines that in the manufacturing floor need to be maintained. So they shut down that section. They go section by section, shut it down, torque the electrical system, and work on the machines. You have to maintain them. Right now you can maintain it less because of this heat guns, that you can point the heat gun at the bus, and it will tell you if it's hot. If it's hot, means it has loose connection, so you need to go torque it, tighten them. If it's not, so you might be able to reduce the maintenance cycle. But all these equipment, guys, you have to do maintenance cycles with them. Suspension. You have to suspend this system, guys. You have some type of hangers, you look at them, and they have to be supported every 5 feet unless by code, every 5 feet unless the manufacturer tells you otherwise. If they're listed and labeled to be supported every 10 feet, then you support them every 10 feet. Otherwise, the rule is every 5 feet. Here's all the hardware, and I assume that you guys are going to look at this day in, day out. Different type of hangers that you can use to support them. Bracket support. You can actually have a messenger cable, suspend the messenger cable and tie it from a cable. You can have brackets right here. Another type of bracket support. So there's a lot of hardware. Rods. You can use rod hanging. So you can different type of support that you can use to support the system. Eventually, you need to support it from the structural ceiling of the building. These are multiple different support methods. How far you need to support it? Every 5 feet, unless the manufacturer tells you otherwise. Yes, sir.
Are bus ducts the same as bus ducts, or are they different?
Bus ducts, busways used interchangeably. Busways is the code called them busways. Yep, bus ducts, busways are the same. Cable busway is a different story. Busways and bus ducts are interchangeable terms. The code calls them busways. Okay, so that's basically it. Minimum number of size required, protective ratings. Here's the project that we have. Look at this. I thought this is really nice. Number of bus plug-in required, and protected device and switch. So I have 47 plugs, and these look like this, guys. 47 plugs with a fuse, right? 47 of them. Each one of them is 15 amp and residing in a 30 amp disconnect. So they look something like this, right? So that's what they're telling us here. So this I have, right? And this is 30, this is, what is it, 15 amp? 15 amp fuse, this is 30 amp disconnect. This assembly, a disconnect fuse, I have 47 of them in our project. These are the ones that you're looking at right here. These little machines here, these little disconnects, 47 of them. And you can imagine, I'm going to go all the way to this 90 amp, and they're sitting in 100 disconnect. 100 disconnect, 90 amps. Remember the disconnect 30, 60, 100, multiples of hundreds for the most part, and overconnection device based on the code. You guys are going to have a schedule like this for Chad in your project, because you're going to identify the disconnect as the fuse. Now, can I use a circuit breaker instead of fuse disconnect? Yes, you can use a circuit breaker. So that's all what I have in terms of the busways. Let me just quick see if I can go through these nice slides here. We talked about this one. This is how the hardware, guys, looks like. When we go to Boston Scientific, you're going to be moving and looking at all these busways and all these ports coming out of it. This is your disconnect. It has a little hook on it for your disconnect, and usually have a a stick there with a little hook so you can disconnect the system to isolate it. Disconnects, different type of disconnects. We looked at this one. Here's how they sandwich them. I don't know if you guys can see. This is interesting. They have the phases. Let's just, I'm going to dare to say this is phase, oops. This is phase A, phase B, phase C. And there's also two sets of phases, phase A, phase B, phase C. So they have depending on what the amp is, every phase could have multiple bars of copper, The cross-section area, guys, of this copper could be 4-inch, and depth, I don't know, let's just say 1/4 inch. I'm going to dare to put, so the depth, say 1/4 inch by 4-inch, and how long? As long as you want it. And at the end, they will be tied because they're parallel. At the end, the A's will be tied together, the B's will be tied together, and the C's will be tied together. You can have multiple bars, bus bars inside this this busway. You have your support insulation. You have to insulate them, otherwise it will short. Insulating grabbings, and of course the housing, the upper enclosure to house it, and the lower enclosure. And Chris, everybody knows why this is ventilated, right? Why do you think it says holes in it? It allows these buses to ventilate. Otherwise, they will, if you allow them to ventilate, to conduct the heat away from them, they can carry this amount of amps. If you completely enclose them, like if this is to be outside, rated for wet location, I can't use it. It has to be weatherproof. So you completely enclose it, then you have to derate. You get into a whole lot of different derating. So that's your busways. Different look at the busways. Tied to straps, insulators. This is where you can tie to cables. We talked about this one. Torquing them and adjusting them. Okay, so that's all we have. Let me just quick, guys, I have a few minutes. I'm going to walk you through the NEC code book requirement for this baby. So if I may go directly into my NEC code book, do me a favor, go to Article 368. 368, very quick. If you guys go to Article 368, are you guys 368? 368. When my code opens. Come on. Okay, if you guys are at 368, the first thing it will tell you, this is page 225 in NEC code book. It will tell you the scope. You can use it as service entrance, feeders, and branch circuit. Very, very important wiring methods. There are 3 different circuits very dear to your heart and mind in the code. One is service, feeder, and branch circuit. Can I use this as a feeder or a branch circuit? Yeah, bring it on. So look at where it's located under wiring methods, and if it's what did they say, 368. So let's go to 358, Chad, 368 right here, busways, and if you expand that baby, okay. So the most important thing I want to emphasize, guys, can you guys see if it can be used as service, feeder, or branch circuit? Bring it on. They define it. You have to have an equipment grounded conductor, or the frame have to be identified as an equipment grounded conductor too. Grounded metal enclosures. The enclosure have to be grounded. Installation uses permitted. You can use it exposed. Most of the time, you cannot use it concealed. You can put it behind access panels. For example, can I put a bus duct right behind this, above the suspended ceiling? No problem. I have access to it. Can I conceal it in the wall completely? No. Can I take a busway right through this wall to the other side, passing through a wall? No problem. Just to pass through the wall, not in the wall, not completely in the wall. You have to pass through the wall, no problem. The section that passes through the wall have to be no plug in it. So you can go from room to room, but you can't conceal it though. It has to be exposed for the most part. So this talks about the use through walls and so forth and floors, and if it's mostly indoor, if it's outdoor, it has to be rated for used outdoor. So use is not permitted If it's physical damage, you can use it unless it's listed for that hoistways, hazardous location, unless it's listed for this wet location, unless it's listed. If you're using it as a light, busway to tie lights, it have to be at least 8-foot high. If you guys can see right here, if you're using it to feed light, it has to be over 8-foot high. You need to have an overcurrent protection, guys, for the busway that's equal to the busway or less. Okay, so that's a couple of things about overcurrent protection device. Wiring methods, Chris, what type of wiring methods can I use out of this baby? I can support. Remember that we talked about the support? I bet you that was wrong article that I showed you. Here's the support. You can see 3 feet support, unless listed otherwise. Branch circuit and busways. Ashley, can I tab an AC cable or an MC cable from a busway? Yep. Well, how do you know it's right? Because the code says so. I can support an MC cable, AC cable, on my cable, rigid con. All these are allowed to be tabbed out of a busway as a branch circuit. Cord. Look at these cords and cord assembly. SO cord, like we do it all the time. Can I do an SO cord from this? No problem. Bring it on. So these are what this little shy article tell you guys. There's limitation on when you have a support. You'll see later on when you have a support, you have to when you have a cord, you have to support the cord so the cord is not dangling from the busway. So you have to have support every 6 inches or so, 6 feet. Branch circuit, dead ends. You have to have a dead end so people can stick their hands and get electrocuted. It has to be grounded. And it talks about the construction, guys, how it's made. And oh, by the way, can I have a busway, medium voltage busway? Yep, they have also a medium voltage busway they can use with medium voltage requirements. So I'm not going to talk about the medium voltage. So this is a tiny little shy article, guys, that talk about the busways. Not a whole lot into it. The most important thing is the support, overcurrent protection device, when it can be used, most of the time in a dry location, unless it's listed for wet location, and the type of wiring methods that you can take away from this system. Any question about busways? Any question about busways? So that's what I was thinking. Let me just go back into 3 here. Any question, guys, about busways, the support that we can use? You can see how they did this busway in our project. You guys are going to mirror this, and you're going to use it in your project. When we deal with our project, our manufacturing floor, all these owner equipment that I gave you a list of, all these owner equipment is going to be tied directly from the plug-in busways. You're going to use a feeder busway, plug-in busway. A lot of companies, guys, if you have a 4,000 amp switch here and you have the transformer sitting outside, you know what they do? And instead of pulling 12 conductors, 12 runs or 11 runs of 500 kcm each set, what they do is they put a 4,000 amp busway directly from the transformer all the way to the building. Of course, if it's outdoor, it has to be in an enclosure that's rated for outdoor location. Any question about plug-in busways, feeder busways? Trolley busways, they have a chapter that talk about trolley busways, a little bit more details, how they do the contacts and so forth. Any question about this? Last thing before you do, and you guys are not done with busways because we have 4 examples, calculation that we're going to use to size plug-in busways and feeder busways later on, calculation. I want you guys please to go to, the last thing I want to show you, is if you go to page 312 in DeWalt, you're going to find all the standard busway sizes. 312 in DeWalt. If you guys page 3-12, if you, I'm sorry, 3-13, right? 3-13. If you guys look at the left-hand side of that page, busway or bus duct, can you guys see the single phase and 3-phase? Ignore the single phase. Always look at the 3-phase. You can't buy a smaller than 225 amp. Well, you can if you custom design it. So the smallest plug-in busway you're dealing with is 225 amp. These are not 15 amp busway, plug-in busways that you can install. These are major equipment, guys. So you start with 225 amp, then 400, 600, 800, 1000, 1200, 1350, 1600, 2000, 250, 2500, 3000, 4000, and 5000. Everybody can see the standard sizes for the most part. These, Jackson, my friend, these these will be the ones that we're going to be using when I do calculation about busways. These are the ones and you go size of busway, you're going to go to this sheet. Any question before I give you a 5 minutes break? Any question? I know this is a new topic for you. So basically, this is all what you need to know about busways. Unless you're going to install them, then you have to have some training in how to torque them and all this. It's not a big deal. You just have to go through the hands-on mounting and the rods and so forth. There's a lot of mechanical skills you have to gain as you work with them. Some of these busways, guys, are so heavy. When we go to electromechanical EMI, when we go to EMI here in Plymouth, they'll show you big duct that needs the cranes or lifts to lift these busways as they mount them. A 4,000 amp busway is a heavy piece of equipment, a 10 foot of it. So you can't carry it. You have to have some type of a lift to lift it. Okay, any question? All right, let's take 5 minutes.